All right, so thank you everyone for joining us today for the proposal presentation of Jabbar, Abdulrahman Alabduljabbar. And so Jabbar, by our earlier discussion, you will have 45 minutes, incorporate any questions that you might have in the way. And then we will have an open floor for discussion by the faculty members and students on the call. With that, please take it from here.
All right. Thank you, Professor Mohsen. Hello, everyone, and thank you for attending my proposal. Today, I will be presenting my dissertation proposal titled Towards a Holistic and Comparative Analysis of the Free Content Web, Security, Privacy, and Performance. First, let me introduce myself. I am a computer science PhD candidate at UCF, where I started my work in 2019 under the supervision of Professor Mohsen. I obtained a master's degree in computer science from the University of Glasgow in 2011, and my bachelor degrees in computer information systems from King Saud University in 2008. My research interests are in the area of user-centric, web security, and privacy. I'm also interested in data mining and machine learning applications to vulnerability understanding. The outline of my presentation will be as follows. First, I will start with the background on the web security analysis and online services types, which are the core of this dissertation. Then I will present the first thrust of my proposal, the online services risk assessment. After that, I will present the second thrust on analyzing the privacy and security of online users and data. Then I will move to the third thrust on investigating the online privacy policies practices. I will also list the work to be done toward the end of various thrusts. Finally, I will conclude my work and answer any questions. Before diving into the user security and privacy on online services, let me provide a brief background on web analysis. So analyzing websites enables understanding their security and vulnerability exposure. And given the various features of those websites, the analysis can be divided into several categories, such as the domain level analysis, content level analysis, and third-party practices. The domain level includes any features that can be extracted using the URL or the IP address. And this may include extracting the top-level domain or the domain creation date. Other features such as the hosting infrastructure and location of the host also included in the domain level analysis. Then we have the content level analysis, which may include analyzing the type of content uploaded into the website, or other certain or other attributes of the malicious hosted content. The third one is the third-party practices analysis, which include analyzing the third-party features, such as the SSL certificate or the privacy policies and information sharing practices. So in terms of web services types, and for the purpose of this dissertation, we will divide the web services into two main categories based on their profit model: the free content websites and the premium websites. We define the free content as any websites that provide physical or virtual services free of charge. And some of these websites were run on donation or revenue from advertisement. The other type is the premium group, which contains the websites that provide content using subscription-based or pay-as-you-use model. To understand the rest of this proposal, we will provide a high-level problem statement around three main research questions. The first is how different are the free content websites from premium ones that provide the same type of content? The second question is, are there any significant differences between the two types of websites in terms of the structure, the content, performance, or other security property. The third one, do the free websites come with a hidden cost to users, which would outdate the perceived value of free content of the free stuff? Therefore, we formulate our research goal as exploring the potential user privacy and security vulnerabilities among online services. Let's start with the first thrust of this dissertation, the online services risk measurement. And in this thrust, we will study the safety and security of free content websites on the web. And toward this goal, we will perform several security and performance analysis to assess and measure the risk associated with those websites. And to start, we perform the analysis across the dimension that we mentioned earlier. For the domain level analysis, we analyzed three main aspects: the top level domain, and the SSL certificates, and the domain creation date, which are commonly used in the literature. The second one is the content type, or the content level, where we analyzed several performance features such as the HTTP request and content type. And also for our risk analysis, we examined the maliciousness of websites content, such as images and JavaScript. We also performed risk modeling to find the significant differences between the free content and premium websites by building a machine learning algorithm that utilized the domain and content level features to predict the risk associated with those websites. And the objective of this thrust is to explore the structural differences between premium and free content websites. Toward this objective, we collected more than 1,500 websites that offer free and premium content. And those websites were obtained from the top search results of three search engines: the Google, and DuckDuckGo, and Bing. When selecting the website, we considered the most popular ones that provide free or paid content services. We then crawled those websites to obtain their content, including scripts, images, HTML, and other files formats. We then manually examined the labeled. We then labeled each one of these websites to either premium or free, and then categorized them also manually into 5 groups based on the content that they provide, either to books, games, movies, music, or software. And we found that the average file extracted from premium websites are often way larger than the average files of free content, as shown in the table. After obtaining the URLs and files, we expand the dataset with other attributes, including the top-level domain information and the domain creation date using whois service. Moreover, we extracted the SSL certificate attributes using API void. We then utilized the SolarBin's Pingdom API to collect other features related to content, including HTTP request, page size, average load time, and the content type. For our risk analysis, we used 2 main popular online APIs, the VirusTotal and Sucuri, to assess the security risk associated with the free content websites and examine the maliciousness of their content. Using VirusTotal, we examined the website's URLs and the files to detect their maliciousness. And we used Sucuri to study the vulnerability of those websites and the blacklisting. We then performed the risk modeling by utilizing the domain and content level features to create the risk boundary of these websites and differentiate between them in terms of their risk. So let's start now with the results of the website analysis. Here we are trying to show the distribution of free content and premium websites among the top-level domains. Overall, we found the .com is the most popular top-level domain with 80% of the premium websites and only 44% of the free content website using .com as a top-level domain. However, there are 98 other unique top-level domains used by the free content, compared to only 24 used by the premium websites. We then examined the website's creation date, and we found that an increasing number of the newly created free content websites, in contrast to a declining number of the newly created premium domains, especially in the period of 2015 to 2021. And that observation actually motivates us to explore the risk associated with such websites. For our SSL certificate analysis, we found that the free content operators are not renewing their certificates, maybe unwilling to increase their operational cost, which will lead to potential risk regarding user information and data privacy. The figures shows that 36% of the free content websites are having issues with their SSL certificate, compared to only 7% of the premium services. In the content level analysis, we found that the number of HTTP requests which are made by a client to access a server resources in premium website is only 2 times more, whereas the average page size is 3 times higher. So that means visiting a free content page require more HTTP requests for the same amount of data. And that's mainly results in redirection or advertisement content, where each redirection triggers 1 or more HTTP requests and consumes more time for loading. In the same way, we can see that the average page load time is still comparable across the 2 groups, which might show the degraded performance and extensive usage of redirection of the free content websites. The second part is the content type analysis, where we are trying to understand the distribution of the website components or files, including the images, JavaScript, text, HTML, and other file formats. We found that the images are the most common components, followed by the JavaScript. And as the figure shows here, that the overall free content websites are having 15% less images and twice redirect content and 1.3 times more JavaScript. Another issue is the higher usage of redirection in the free content websites, and as the redirection actually is the main method to deliver advertisement or to mislead the filtering algorithms. Next, we will discuss the maliciousness analysis, starting with the malicious URLs detection using the VirusTotal API. And we found that 38% of the free content are considered malicious by VirusTotal, compared to only 2% of the premium websites. And the free content URLs are detected as malicious, ranging from 20% in the books category to 60% in the software category. In contrast to the premium websites having a low detection rate, ranging from 1% to 4% only. A significant number of those detected websites were labeled as malicious, and only 9% of them were labeled as phishing websites. While the number from the previous slides of the malicious URLs in premium websites is only 2%, the number of their files labeled as malicious is 17%, compared to 45% of the free content websites, which contains malicious files. And from this table, we find that the majority of the malicious files are having .gif or HTML formats. And we manually inspected some of those malicious files, the .gif files, and found that the majority of them are advertisement-related content. For the website's vulnerability and blacklisting, we used the security API to find that In the free content website, they are having 12% of their websites were detected as containing malware, compared to only 1% of the premium counterparts. And the free movies websites have the highest percentage of malware detection with more than 16%, and the free books and music have the highest percentage of vulnerabilities. For the premium websites on the right, 17% of the software were labeled as vulnerable, and according to the security reports, the high percentage is because of the outdated framework versions. Before moving to the risk assessment and modeling, here we are showing the features that we use to represent the website, including the SSL certificate features and the page size, load time, top-level domain, and the website content features. However, the data that obtained by VirusTotal and Security, the ones between the 15 and 22, is held out and only used to validate our model. We also included 3 more features extracted using Security Trails API, which are the IP address lifetime for each website, and whether a website used or using the Cloudflare as a content delivery network, and whether a website is using or previously used the Akami Tech as a content delivery network. So one of the main goals of this study is to establish the risk boundaries between risky and risk-free websites. And for this goal, we use the support vector machine to identify the risky website with an accuracy of 86%. We then use the TSNA visualization to convert the extracted features of those websites from multi-dimensional space into 2 dimensions, where the red dots represent the free content websites and black dots represent the premium content. And we are trying to show the possibility of differentiating or segregating the free content websites from the premium websites. And through our domain level analysis, we found that free content websites are newer and their growth is increasing. And throughout the content level analysis, we found that the free content websites have higher page load time compared to their page size, and they have a higher portion of redirections, as they are the primary methods to deliver advertisement. And to assess the risk associated with free content websites, we found that they are more likely to be associated with malicious web activities, as 38% of them blacklisted, and 45 contains malicious script. So to conclude the first thrust of this proposal, we have conducted a comparative analysis of the online content websites, and by experimenting various domain and content level dimensions and assessing their risk boundary, our findings shows that the free content websites are more vulnerable and more likely to contain malicious content or malicious behavior. Now we will move to the second thrust of this dissertation, the online user and data privacy analysis. And this thrust focuses on the analysis of SSL certificates of the free content websites and study how they are different from their premium websites. In this thrust, we explore the fundamental and structural differences between the free and premium content websites, and we focused on the SSL certificate content and information, as it is important to study these certificates since they are having as a valid certificate will enable secure connections between the client and the server. And obtaining the certificates of the websites can provide us with various pieces of information, which include the domain name, the certificate authority and its validity, and also the certificate signature algorithms. The most common issues with SSL certificates are the untrusted SSL certificate, where the certificate is not signed by a trusted authority. So the website in this case publishes a certificate self-signed by the server. The second issue is the domain name mismatch. And this happens when the website's URLs different from the domain name in the certificate. Then we have the mixed content warning. And this warning is issued with unsecured or malicious or exploitable content. Then we have expired SSL certificates, which may result in out-of-date security practices. So these issues motivate us to understand the differences between the free and premium websites in terms of their SSL certificates. And to augment our data set, we used our previously compiled list of the free content and premium websites to extract various certificate attributes by using API void and OpenSSL command line tool. For our analysis, we started by analyzing the validity of SSL certificates, and we found that the free content websites are up to 6 times likely to have mismatched domain in their certificates. We also observed that the free content websites are more likely to have expired certificates with a percentage of 24% in comparison with 6% of the premium websites. And overall, we noticed that 12% of the free content website certificates are invalid compared to only 3% of the premium content.
I have a very quick question on this slide. Can you go back?
Yes, sure.
Why do you use the 6x here, but do not use 4x here or whatever that number is, or 4x here? Is there any reason?
Just we are trying to show the high the large difference.
I understand, but what do you this is something I not really noticed earlier. Why do you use 6x here, but here you use the percentage? And the next, in the first slide, SSL mismatch domain, you use 6x, which is okay, it's good. And SSL expiration 6 versus 24, which is good, which is okay. But why there is inconsistency in that?
Oh yeah, I got your question. Actually, yeah.
Okay, never mind. Just carry on. But just for consistency. Okay, carry on.
Oh yeah, sure, Professor. So next we will analyze the number of days left until the SSL certificate become invalid if not renewed. And as shown in these figures, the average validity duration in the premium website is much higher than the free content website, especially in the games, movies, and software categories, which result in the increase in the overall average. On the issuer organization level, we uncover the heavy usage of Cloudflare services by the free content websites for their certificates in comparison to only 16% of the premium websites. And moreover, while the DigiCert is not commonly used for free content, around 23% of the premium websites rely on them for issuing the SSL certificates. And to show the exact differences in percentage between the certificate issuer organization of the free and premium websites, the table here shows that Cloudflare and Let's Encrypt are used more by the free content, and the DigiCert is used by the premium websites. While there are noticeable differences between the free and premium content websites on the organizational level, we found that on the country level, the differences are not as significant, as most of these websites or the content, the CDNs are located in the United States. So we have them in both categories as the highest percentage. And now we move to studying the signature algorithms used by these websites. And we found that 60% of the free content are using SHA-256 with RSA signature mechanism by following the #10 sign mechanism. And the majority of the premium websites are using the same algorithms combination with a difference of 23%. On the other hand, 38% of the free content websites rely on the newer and faster ECDSA algorithm, which uses the shorter keys for the same security level as in the RSA, in comparison with less than 17% of the premium websites. In addition to analyzing the key algorithms, we also investigated the commonly used key size among the SSL certificates. And overall, we noticed that more than a third of the free content websites are still using the 256 bits keys in comparison with only 20% of the premium content. As the key size, as they use the key size of 2048 bits, is commonly used among the premium content websites, and this is more common in the games and movies and software categories. So analyzing the free and premium content websites on the SSL certificates, we found that free content websites are more likely to have issues with their certificates, while on the issuing organization and country are similar for both websites. We noticed that the free content websites are adapting the more recent ECDSA algorithm, with a third of them using the key size of 256 bits. And to summarize this thrust so far, we found that 36% of the free content websites are having issues with their certificates, which recalls for consistent monitoring of such websites. And up to this point in this dissertation, we highlighted that free content websites are more likely to be associated with malicious content and activities, with a large portion of them having invalid certificates. To extend this work, we will analyze the HTTP header features to investigate the infrastructure and behavioral differences between the free and premium websites, as the HTTP headers or the HTTP header features can include the security-related features such as the strict transport security, set cookies, and other attributes as the connection status code or the server type. We also, including the HTTP header features in our analysis will result in a more accurate risk assessment, and that will enable the detection of malicious website using easy to extract features. Now we will move to the third thrust of this dissertation, the online services privacy practices analysis. So privacy policies are are legal statements, and they are the primary channel where the service provider inform users about their data collection and use practices. And typically the data practices are embedded within the privacy policies or the terms of use, which reflect the service provider behavior and security concerns associated with the usage of that service. So in this work, we are trying to study the data collection and sharing practices among the free and premium websites, and trying to find the main differences between the privacy policies in the two groups. So just as an introduction and as online, so just to follow the same categories that have been proposed in the literature, we start by categorizing the privacy policies into 9 different categories, or the paragraphs actually in the privacy policies. The first group is the first party collection, which is about what data is being collected by a service provider. Then we have the third party sharing, which discusses what data is collected and shared with a third party. Then we have the user choice, which is about whether users have control over their data. We also have the user access, and it discusses how users can access or edit or delete their data, and if the service will allow them to do so. Then we have the data retention category, which is about how long the stored data, or the how long the service provider servers will retain or store the users the data of the users. Then we have the data security, which is discuss or describe the method of securing or protecting user data from different types of breaches. We then have the policy change, which describe how a service provider inform the users about any changes in their policies. Next, we have the do not track category, which describe how a service provider honors the online and ad tracking. We have the specific audience, and that will, like, if we have a paragraph targeting a specific or discussing a specific group of users, for example, children, Europeans, or California residents, as an example. Then we have the other category, which contains the other types, or the one that does not relate to any categories and just includes the general information not related to any of the previously discussed categories. And so we use these high-level categories as labels to implement an automated annotator. We call it TLDR. So we use that or we can call it annotator or classifier to extract the reporting practices of the free and premium online services by analyzing their privacy policies. So before discussing or before moving to the proposed model or the annotator, and to understand the privacy policy reporting of the free and premium content, we started by extracting the privacy policies of the aforementioned compiled websites, and after extracting the privacy policies, we manually verified the validity of each extracted policy, so we can have accurate reporting for the observations and our findings. And so in order to build our privacy policy pipeline, we started with the following steps. The first one is crawling the compiled online websites and extracting their privacy policies. And for our crawling, we used the Selenium driver, which is an automated framework that provide extensions to simulate or to emulate the user interaction with browsers. And so the Selenium driver will search each web page of each website for terms such as privacy policy or privacy statements or other privacy related terms. And once any of these terms found, the associated or the related HTML will be saved, so we can use it for the next processing step. So then after downloading and saving the privacy policies, we perform the cleaning step or the segment extraction, where for each privacy policy we extracted the segments or the paragraphs, and we use the beautiful soup Python library. After that, the TLDR or the annotator that we used take place by classifying or associating each paragraph to one or more privacy categories from the categories that we discussed before. So in the next slide, we'll discuss the pipeline design of the TLDR annotator. So for our pipeline, and after experimenting several configurations, and from our experimental evaluation, we demonstrate the capabilities of BERT transformer, as we will show later on this presentation. So the BERT model actually is also combined with the word piece for word representation, and then we use the model for segment level annotation or for paragraph annotation. So the BERT model or the annotator will output a binary decision for each segment or for each paragraph to check if it's related to any of the previously discussed categories, and this binary will be as a positive or negative. The positive outcome will indicate that the segment contains information about the privacy policy category, and while the negative outcome will indicate that the segment does not contain such information. So in our experimental setup, we trained the proposed pipeline using OBB 115 dataset, which is a compilation of 115 privacy policies manually annotated by 10 law school students. We use the document level splitting approach, which when we trained the model by using 80% of the privacy policies themselves as a test against the remaining 20% used for. Sorry, we used the document level splitting approach by training the model using the 80% of the documents or the privacy policies, and then we performed the testing on the remaining 20%. Then for our evaluation, we used the F1 score, which is the harmonic mean between the precision and recall. We used the F1 score as our evaluation metrics. So after discussing our pipeline structure, we are showing here the performance of our proposed classifier, and this all reported in F1 score, and we are showing here the best performing word representation by using the word piece and the learning algorithms using the BERT transformer. So our evaluation shows that the TLDR outperforms its counterpart by a large margin with 91 overall F1 score, and the highest difference is in the data retention category with 87 F1 score if we compare with other models that trained on the same data set. So then we used the implemented annotator to study the privacy practices reporting and for both the free and premium content websites. And the table here shows that the percentage of websites containing information regarding each privacy policy category. So the finding here shows that in general, premium websites are more likely to report their data collection and sharing practices, despite the fact that free content websites having longer privacy policies. And moreover, we noticed that free content paragraphs are less likely to contain useful information regarding the data collection practices, as the table here shows that the percentage of segments highlighted by the TLDR annotator for containing information of a category of interest. And when we look at the last row of the table, that the all categories, we can see that in all of our 5 groups, the premium websites contain higher percentage of the highlighted segments or the segments that include useful information. And this will indicate that the premium websites are more to the point, while the ambiguity rules the free content websites, in particular for the first party use category. In addition, we also explored the privacy policy similarity among our dataset using the TF-IDF and cosine similarity. We extracted the similarity per sentence among the privacy policies, and we noticed that free content websites are more likely to have similar privacy policies, indicating a potential usage of generic templates among those websites. So, the findings from this thrust among the other findings in this dissertation, we can show that premium websites are more transparent and to the point in reporting their data sharing and user tracking practices. Moreover, the lack of transparency in free content websites are concerning. For example, 0% actually from the gaming free content websites reported their user tracking practices. In contrast to the premium content free, the free websites contain less information or less useful information, trying to hide some potential risk of using their services. So among other findings, we uncovered that free content are more likely to use generic privacy policy templates. And this indicates that the privacy policy may reflect the actual data collection practices used by the website service providers. To summarize this thrust so far, we study the free and premium content websites reporting practices by uncovering the lack of reporting for their data collection in the free content, in addition to reusing general templates, which calls for further investigation. And to extend this work, we will investigate the commonly used data collection and privacy practice among other among popular websites, namely the Alexa top 10,000 websites, and how the general practices compared to their free and premium content websites. And to do so, we will use the implemented model, the TLDR, toward analyzing Alexa top 10,000 privacy policies. This will allow us to uncover the privacy policy reporting differences between Alexa top 10,000 websites and the 2 groups of free and premium content websites. So the ultimate goal of this study is to provide a better understanding of the trade-offs between the provided service and the privacy of users. With that, I conclude my presentation. And here is the list of the publication that contributed to my proposal. Thank you for your listening, and I'm happy to answer any questions.